So, good morning, good afternoon, good night, everyone, wherever you are, and whatever time it is when you're watching this. So, the article that I chose was called Open and Closed Mathematics. So, a brief introduction. So, there's been a growing concern for educators that students are learning math or abstract mathematical concepts from K through 12, but not actually able to apply the skills that they'll learn outside of school context. So, for example, they get an equation y equals mx plus b, but don't understand how this is a rate of change and how this can apply in any context outside of the math classroom. So this has led to a push toward teaching open-ended, practical, investigative work that teach mathematical concepts in real-world applications. So actually seeing how the math comes to life. So that's the difference between open and closed mathematics, just FYI. So let me tell you a little bit about the study. So a longitudinal case study analysis was conducted by Joe Boaler, who's the author of the article, to investigate and compare teaching practices of two different schools, one using closed mathematical instruction and one using open mathematical instruction. So over 100 observations were conducted, student interviews and student assessments were analyzed. So let's look at the two schools. So the first school is called, for the sake of the article, is called Phoenix Park. So this school uses process-based mathematical approaches. It's a small school of about 110 students, and the lessons are pretty relaxed with less rules. And the main work for them consisted of open-ended projects of mixed ability groups. So the projects will last 2 to 3 weeks, and then there will be a new project, and all of the projects will have the concepts that they're learning in math, and it'll be throughout the whole year. Now it was probably only maybe like 3 weeks in the year where they would actually like do closed mathematics for assessment purposes. And I guess it's a typo. So the second school is Amber Hill, and it had about 200 students. So this school was run by an authoritarian head teacher. So if you think about like Matilda, that kind of vibe. The students worked through textbooks throughout the entire year and only spent about 3 weeks on open-ended tasks. So there was very much reversed from the first school. The environment was very quiet and controlled, and so you could drop a pencil on the ground and you wouldn't hear you would be able to hear it. So what did the researcher do? So the researcher observed over 100 lessons and took notes for each school. She assigned open-ended tasks that had real-world applications to the mathematical concepts that they were learning, and she also assigned short closed questions. Finally, she interviewed students from each school to understand the relationship between learning mathematics as well as their relationship to real-world applications of mathematics. So what did she find? So she found out that the Phoenix Park students performed much better on open-ended tasks because they had the mindset, they were already predisposed to doing open-ended tasks. And actually, surprisingly, well, not surprisingly, really, there was no significant difference in performance on closed tasks. So you would think that the Amber Hill students would do better since all they were used to a closed task, but there were actually no significant differences. And then Amber Hill had relative underachievement in formal testing situations as opposed to Phoenix Park. So let's talk about why this was the case. So after a discussion with the students from both schools, the researcher found some interesting differences. Amber Hill students rely mainly on rehearsal and procedural memory and often panicked around assessments that require extended thinking and applications of concepts learned. However, Phoenix Park students were predisposed to think about and use mathematics in novel situations. However, most students spent a lot of time not working. So again, remember they had all these open-ended projects. So because they were group projects, a lot of time they were not doing the actual group work until probably the very end. They probably procrastinated and did everything at the very end of the due date, closer to the due date. So my key takeaways from this is that the open-ended tasks were much more relevant and definitely helped the students to be able to see real-world connections of the mathematical concepts learned. I think that from what we're learning with the 5 practices on how to facilitate productive mathematical discussions, that a lot of the project-based learning time was not used effectively on the teachers' parts because they probably just didn't know how to monitor well and engage the students on a daily basis so that they're actually engaged in the concepts. Um, I think there needs to be a balance between open and closed instruction more emphasis on open instruction since it does have real world applications, but I do think that there should be more times that closed instruction is taught as well because I do see some benefit in it. Like, I'm the type of student when I was in school, I like to have the abstract formulas that I could apply to the situation. So if I have a quadratic expression and I wanted to find the roots of the quadratic expression, I would like to have the quadratic formula at hand just so I could just plug it in, plug and chug, or things of that nature. So I think there needs to be a balance between open and closed instruction, but more so on the open-ended side. So I would give it like a 70-30. But that's my takeaways. So I hope that my little video was informative of the article I read. Thank you for watching. Have a great rest of your day.